Hi everyone, today I will demonstrate how you can create a custom data visualization using Vega visualization grammar. As an example, I will use my Vega implementation of the warming stripes data visualization. This example is available on the examples page of the Vega website. This data visualization shows a difference between temperature of each of the years displayed on this chart and the global temperature, average temperature in the baseline period, which is 1951-1980. So each vertical stripe on this chart represents a difference between the temperature of the year represented by this stripe and the mean of the baseline period. So 0 or white color on this visualization is the mean value for the baseline period, and bluish colors means that this year was colder than the average year in the baseline period, and the reddish stripe means that this year was warmer than the average year in the baseline period. Let me switch to the Vega editor and I will explain how this visualization can be created step by step, and I will explain every Vega property in the JSON specification. This is the existing Vega specification. We have about 200-300 of rows of Vega JSON here. I will remove everything and start from an empty Vega specification. First of all, to start writing Vega specification, we need schema definition. I will copy paste it. So it's schema property and the URL, which is the same for all our Vega visualizations. Then we can add optional description property with some short explanation of what this is all about. So it's going to be warming stripes chart, originally designed by Ed Hawkins. And we can add also optional user meta property, which allows us to add as many custom properties as we need. I will copy paste from the existing specification so we can define as many custom properties as we need and write some additional information about this visualization, like copyright, permissions, some additional URLs to the data source, to the additional information about this visualization, and so on. We are not limited. We can add whatever property you want inside of the meta property, some additional comments, and so on. In the Vega editor, Alt, Shift, F combination on the keyboard will format Vega JSON. You can see I added some blank rows when I use Alt, Shift, F. It will be just reformatted into readable JSON. You can see the full list of keyboard shortcuts here under the commands. The next property to define is going to be background. It will define background color of our data visualization, so it's going to be just white. Or we can use hexacode, which will be like this. Then we can define width of our chart area. 650 pixels, and height of our chart area 200 pixels, and padding. Padding is white space around the chart area, which is going to be 10 pixels on the top, on the left, on the right, and on the bottom. Then we can add auto size property, which will be fat, to make sure that our area for the chart, legend, title, and all items in our visualization will be automatically resized to make sure we have enough space for all elements of our data visualization. And next property is going to be signals. Inside of the signals property, we can define the signals or our constants and variables. I will leave it empty for now because usually I create the specification and then I already understand what signals I need and I can replace some hard-coded values with the signals. So for now, the signals is going to be empty. We will add them later when we understand for what purpose we need each signal. The next property is going to be data, so we can load our data. We can define as many data tables as we need. Let me add the rows here, so it's on the top of the screen. In this case, we need just one simple data table. So the name of this table is going to be dataset, and it will be the data loaded from CSV file stored in my GitHub repository. So I will just paste URL here into the URL property, and I need to let Vega know that this file is comma separated CSV file, so it can be parsed properly. So the next property is format, which defines type CSV, parse auto, delimiter, comma. Now you can see here in the data viewer that we have dataset table already loaded, and it contains two columns, year and temp, which is the difference between this year temperature and the average of the baseline period. Then we can start defining some scale. For this visualization, we need a scale for the years or for the axis X, but in Power BI Core Visuals, we can usually define just if our axis is visible and scale is available by default for this axis. In Vega, we can define as many scales as we need, and we can define for each scale as many axes as we need. So, for example, here, the same scale used for distribution of the years along the visualization is used to create two different axes or visual representations of the scale. So we have axis on the bottom with some labels and tick marks, and we have another axis on the top with the baseline period, and both axes are based on the same scale. So scale defines how our data from the table year column will be distributed along the chart, and each axis just defines what the tick marks or labels or domain lines will be visible and in what position on the bottom or on the top of our visualization. And one more scale used in this chart is the scale for this for this line that is moving along the vertical legend. You can see that it shows the temperature difference on the cursor. So it's when I selected the last year, 2023, it's on the top because it was the hottest year in the entire chart. And when the cursor is here on the white, you can see that this line is here on the white, which means the average temperature in the baseline period. So we need one more scale and one more axis for this functionality. So this is one more axis, but there are no labels. There is just this single tick mark on this axis. I will explain it later in the code. So let's add some scales. I need to close the text here. First scale is going to be name scale X, which will define how our years are going to be distributed along the visualization. Type of this scale will be linear. Domain property defines what data we need to distribute along this scale. So it will be based on data table named dataset. And from this dataset table, we need field, which is year. So domain property defines that this scale is for the year field from the dataset table. You can see here that we have year field from the dataset table. And the smallest value in this year column is 1880, and the largest value is 2023. So all these years should be distributed linearly, because we have linear type of the scale, along some range in pixels of our chart area. So the next property is range, which will be from 0 pixels to signal width. Let me explain the range property. Here in the range property, you can use just width in this format, and it will mean that we need to distribute all our years along the entire width of our visualization. But this way to define range, it's just syntax sugar for this format, which means that our years should be distributed along the range which starts on 0 pixels from the left, 0 pixels, to width pixels from the left, which the entire width of our chart. This signal property is how you call all your signals or constants and variables. When you want to use value of your signal somewhere in the specification, you can just define signal property and it will call signal named width. We never defined any signal here in the signals, but a few signals are defined not inside of the signals property, but we define it width and height here on the top, and these signals are available without defining them inside of the signals property. So we can say that scale x is used to linearly distribute all our years along the entire width of our chart from 0 to width position on the chart area. And here we need to add 0 false property, because otherwise it will start it from 0 year, not from the minimal year available in the field. So 0 false means that we don't need 0 value on our chart. 0 true makes sense for the bar chart when you define the scale for the bar chart, which always need to start at 0 position. But in this case, we don't need to show 0 year. We need to start from year 1880. So this is why we need 0 false property here. The next scale will be for the tick mark along the legend, and we can add it later when we will have the legend. Now we can start defining some marks, visual elements of our visualization. After the scales, we can define some marks. Marks are visual elements of our visualization, like lines, rectangles, circles, whatever visual elements we need. In this case, it's just simple rectangles. So how we will define our rectangles or warming stripes? We can start from type rect, which will mean that it's a rectangle. Optional property here is name. I will call it stripe. So this mark is a stripe mark, type rectangle. I will explain later why it makes sense to define the names for our visual marks. For now, the next property is going to be interactive, which will be true, which makes our rectangles interactive. They will react to our actions, like mouse hover, mouse clicks, and so on. And then we need to define from on what data table this mark is going to be based. So it will be from, and data is going to be data set. It means that mark rectangle will be generated for every row in the dataset table. So type rect from dataset means create a rectangle for each row from data table dataset. Next property is going to be encode, where we, inside of this property, we can encode all the additional properties of our rectangle mark. And then we will use enter property, which inside of which we define all properties that should be defined only once when we generate this rectangle. Because some properties we will want to update later, because this is an interactive visualization which will react to mouse hover over the rectangles. So we will use enter, and we will use update, and we will use hover properties inside of encode. So enter for the properties that are going to remain unchanged and won't react on our interaction with the visualization. So it's going to be x position of our rectangle, xc, which means x center of our rectangle along the x scale. So xc position of the rectangle is going to be based on scale, which is scale x, and field year. And then let's skip everything else and add update property here. We have position of our rectangle along axis x. Now we need position along axis y, which is going to be y signal 0. So our rectangle will start on 0 position on the top of our chart, and we need to define height and width of our rectangle. So height of our rectangle is going to be, also we will use signal and height signal, or the height of the entire chart area. So you'll need to create rectangles from the top to the bottom through the entire chart area. And we will need to define width of our rectangles, which is going to be signal. And for now, let me just use some hard-coded for pixels, just to make our rectangles visible. So let me explain what is going on here. We are creating a rectangle for every row of our dataset table. So for every year in our dataset table, we are creating a rectangle. Central position along the axis x, so the center of the rectangle along the axis x is going to be based on scale x, which defines that all our years, you can see here, scale x defines that all our years should be distributed from 0 or the left side of our chart to width or the right side of our chart through the entire width. So all years are distributed. So 1880 is here, 2023 is on the right, and therefore this mark property creates a rectangle for every row in the data set table, and the middle of the rectangle is distributed along the axis x or scale x, and it's every rectangle starts on y position 0, which is on the top, 0 position, 0 pixels on the along x and 0 pixels along y is always a left top corner of our visualization. So y0 means on the top. And the height of each rectangle is height, which is height of our entire chart area defined here on the top. And width is hard-coded for now, which is 4 pixels. So every rectangle for now is 4 pixels. How we can make sure that width of our rectangle is automatically calculated depends on our chart width and the number of years we need to show here. We can create a signal. Name of this signal is going to be, let's call it stripe width, and update. So the name is stripe width, and update property is where we will write our formula to calculate the value of stripe width signal. We can use value here for the constants, hard-coded values, or we can use update property if we need this signal to be recalculated. So here under the update property, we can use a formula to calculate the value of our stripe width. It's going to be width divided by length of our data table. So data set is just how we reference our data table. Length of data set defines length of this table or how many rows we have in this table. So width of the entire chart area divided by number of years in our data table, and we will have stripe width for every stripe. So we can replace this hard-coded for with stripe width here, and to add some additional white space between the rectangles, I will modify it a little bit, and I will use width is going to be multiplied by 0.9, so it's a bit narrower than what we calculated. Now we can change the colors of our stripes. To define the colors, we also can use a scale. So scales in Vega are not just for the position of our data along vertical or horizontal axis of our visualization, but scale also can define colors. So we can add one more scale. Name of this scale is going to be scale. Let me copy the existing one. Name is going to be color tokens. Type of this scale is going to be linear as well. And the range for this scale is going to be a custom color schema, which will include the list of colors. Alt-Shift-F to format the code. So now we have color schema, and we need to add also domain property, and data table is going to be data set, and field is going to be temp. What this scale means? It means that for every temp value from our data set table, which can be a negative or positive value, for all the temp values from our dataset table, they will be distributed along the list of the colors, and depends on the temp value, the color from this schema will be selected, or if it's somewhere between two colors, because we have more temp values than we have colors defined here, so the color will be calculated linearly between two nearest colors in our range. And now when we have color schema defined, we can go back to our mark, and inside of the enter property, where we have our xc property defined, we can add one more property, which will be fill property, and it will be based on scale, which is going to be scale color Hawkins, and field is temp. So our rectangles will be colored or filled with the colors based on color Hawkins schema and temp field. So the mark, when it's generated, Vega will take temp value, for example, minus 0.17, and it will use color Hawkins schema to find the color for this value. The problem we have right now is that reddish colors are defined on the top of this color schema and bluish colors defined on the bottom. But our values will be distributed from the smallest one or negative one and to the largest one or the positive one. So we need to inverse this color schema because right now we have reddish colors for the negative temperatures. This is why we need to add one more property here, which is going to be reverse property, and we will set it to true. And also we will define domain mid or the middle of our domain, which is going to be 0. So the middle of our range is white color, you can see here. So the 0 color domain mid, which is defined as 0. So 0 temperature will be associated with the color in the middle of our color schema, which is white. And now we have warming stripes complete. But in this Vega implementation, I also want to add some labels on the bottom for the years. I can show the baseline period on the top, and I want to add the legend on the right side. So it's not yet complete. Let's add the labels on the bottom for the axis X. We already have our scale X defined. Now we can add one more property, which is going to be axis, and our first axis is going to be based on scale X. We need two mandatory properties, which is scale, on what scale the axis is based, and orient, which defines the position of our axis. Is it going to be on the top, on the bottom, on the left, or on the right of our chart? In this case, we need axis based on scale X, and it should be positioned on the bottom of our visualization. And you can already see that we have axis with labels, with tick marks, and with domain line on the bottom. Now we just need to reformat it. First of all, we can disable domain line. This line is the domain line of our axis. So we can add domain property and set it to false to remove the domain line. Domain line has been removed. Next, we can change label color. Label color is going to be defined as value. Let it be gray for now. Then we can replace this hard-coded value with a signal, which will be defined on the top in the signals property. For now, it's just hard-coded gray value. Then we have to remove this comma from our labels. So we need to format our numbers, and 0.4 means that there will be just 4 digits, and we don't need any comma to separate thousands in our label. And then we use encode property to encode additional formatting properties of our axis, which include the sticks, labels, and the main line. But in this case, we have already disabled the main line, so we will encode additional properties for our ticks and labels. Ticks, we encoding additional properties of our ticks, and it's going to be update. Inside of the scale, it should be update, not enter, because enter will apply the same property to all the ticks, and we need update to make sure it will be properly applied to all the ticks. And ticks update by position of our tick value is going to be -3 pixels. -3. You can see that it's probably hard to see. Let me make it -0. There is a small gap between the tick and the rectangle, and -3 it just removes this gap. And then we will encode the additional properties for our labels. Which is going to be Y position. I missed update. The Y position of each label is going to be value 8. We will move it 8 pixels. Let me show it. 0 pixels, 8 pixels. And the next property is going to be font size, which will be calculated using a formula. Signal. Under the signal property, we can write any formula. So if our value, datum value, this is how we call our value from our data table. Datum value, if it's 1900 or if it's 2000, then we will use larger font size, 24, otherwise smaller font size. You can see that we have larger font size for 1900 and 2000 and smaller font size for everything else. Now we can replace the hard-coded values with signals. So instead of using hard-coded font size here and hard-coded label color here, we can start adding some signals. Signal is going to be label font size major, which will be going to be name of the signal, and the value of this signal is going to be 20, and another signal label font size minor is going to be 14. Now we can use these signals here. Instead of hard-coded value, we will use signal name or label font size major and label font size minor. And you can see that we have replaced hard-coded values with signal names. The same for this gray color. Instead of hard-coded value, we will call a signal, which will be label color, label color, unrecognized signal name because we never defined this signal. So we have to go to the signals property and define one more signal, name, label color, and it's going to be value, which will be some gray color, for example, this one. We already have our labels on the bottom, and we have some tick marks and the labels for the years. Now we can create one more axis to add labels for the baseline period on the top. How we can create second axis based on the same scale. Again, we just go to the axis property and we can add additional axis based on the same scale x. But it will be orient is going to be top in this case. You can see that we have additional axis on the top. It's the same axis that we had on the bottom initially with the same formatting, and now we need to reformat it to show our baseline period only. How we can do that? We need to add additional properties to our scale. Not scale, but axis based on the scale x. Let's start from domain property. Domain in this case is going to be true. We need the domain line. Also, we need some offset because right now domain line is somewhere behind our rectangles. Let's move it offset. Is going to be 5 pixels. Now we have 5 pixels between our rectangles and the domain line. So the domain line is visible. Now we need to change label font size to 0 to just remove our labels. We can do it later inside of the encode. Now we can add format property, which will be 0.4 to remove the commas and keep just 4 digits. And then we will start encode section to encode additional properties. First of all, we will encode additional properties for the ticks, and for the ticks, we will define the following properties. Stroke width. Stroke width is going to be based on signal. We either can call an existing signals here, or we can place any formula. In this case, the formula is going to be if datum value equal our base period, which is 1951 base period, start of the base period, or if datum value is equal to end of our base period or 1980, then our width of our tick is 1, otherwise it's 0. One more missing property is, you can see that we already have a tick for 1980, but we don't have a tick for 1951, because by default, we have less tick marks visible than we have years here. We need to add additional property, which is going to be tick count, and tick count here. It's going to be signal. It's going to be length of our data table, data set. Length, which means that we need to show tick for every year in our data set. So there will be 144 tick marks. You can and corresponding labels. You see that we have too many labels. They just overlay one above another. But we have only two tick marks because we have already defined that tick mark stroke width is going to be 0 if it's not 1951 or not 1980 year. So now we just need to remove these extra labels. So we will repeat the same what we did for ticks. Labels property is going to be enter, and it's going to be the similar formula signal. We just need to define font size here inside of enter. Font size. Font size is going to be, let's use existing font size minor. Signal label font size minor, otherwise it's 0. So if year is 1951 or 1980, then label is label font size minor, otherwise font size is 0. So we removed all other labels and have just two labels. And now we need to remove the domain line, but keep it between these two tick marks. How we can do that? We need to add one more property inside of encode, which is going to be domain. We define additional properties for our domain, and it's going to be inside of enter property. Stroke is going to be some color like signal. We can define it as gray for now. And then we will add side of update property. X position of our domain line is going to be based on scale X, and 1951, and X2 position of our domain line 1980. So we are making domain line from X, which is 1951, to X2 position, which is 1980. And now you can see that we have what we needed. Domain line between these two years, two tick marks, and two labels. These years are hard-coded for now. Again, we can replace them with some signals to remove the hard-coded values. So we can create a signal base period start or base period S and base period end or base period E. Let me replace 1951 hard-coded value with the signal name and 1980 with another signal name. And I now need to create these two signals. Let me just copy from the existing code where we have our signals defined. Here I can add two additional signals, base period S and base period E. And therefore, in the code, I don't need to hard code these values anymore. I just can refer to these signal names. The next step is to add a legend on the right. How we can add the legend? To add the legend, we need to define one more property. Where before the marks property, I can add legends. And inside of the legends property, I can define one or more legends. To define our legend, we will use fill property, which is color Hawkins. It means that the type of our legend is based on the color schema, fill color, and it's based on the color Hawkins scale. You can see that a single row fill color Hawkins already created color legend, which shows the distribution of colors based on the color Hawkins color schema. Now we just need to reformat it a little bit. First property we will add is going to be orient none. It will allow us to move the legend into the position that we want it to be. Legend X position is going to be based on signal, and it's going to be width of our chart area plus 40 pixels, and legend Y position is going to be, let me put 0 for now, and we need some padding, which is going to be 20 pixels, and then we can move this to minus 40 or minus 20. Let me check. Minus 20 and padding 20. We can keep it like this. Then we can add some title. Title is going to be degree Celsius. And then we can add title color property, title color, which is going to be gray. Tick count is going to be 10, so we need 10 tick marks and 10 labels, and I will also use tick minimal step 0.2 degrees. So we have a tick mark every 0.2 degrees, and we can change title font size, which is going to be title font size. It will be based on a signal. Let's use existing one, label font size minor. I think I removed title color, which was gray. Okay. And because of larger title font size, it has been moved vertically. We can use minus 40 pixels here to move it back. Okay, and now we can add encode property. encode property, and inside of encode property we will define some additional properties for the labels, and under the enter property we will move the labels. The x is going to be based on some value, which is 3 pixels. We moved the labels 3 pixels to the right. We can define font size here. It will be based on signal. Signal will be legend font size. Now we need to create this signal here. Let me copy paste the existing one. Legend font size is going to be 12. Font size is legend font size. And what else we can define here? I think we need to reformat the labels a little bit. So we need to add update property. The x font size, and then we will use update, and for the update it will be text. We need to change text of our labels, and it will be based on signal. Inside of update we will update the text of the label, and the formula is going to be format datum value plus, which means that we are going to add plus character before the positive values and keep minus character before the negative values. Now we have our legend complete. What is missing is the title and the subtitle. Now we can add these properties to our visualization. Somewhere here, before the marks, we can add title property. And for the title property, we need to define text property, which is the text of our title, which is going to be defined by a signal. And I will copy the formula. Global temperature in, we need to find first year in our data table, to the last year in our data table, in a comparison with our period between base period S and base period E, average value. Right now we have an error because year extent is not defined signal. How we can define year extent signal? We need to go back to our data definition, and we can add transform property here. So we can apply a data transformation, call it extent, which will be based on field year, and it will create a signal, call it year extent. Signal year extent. Extent. Year extent. This transformation will take our data table and into year extent signal it will put two values. The first, the smallest value for 1880, and the largest value in the year field, which is 2023. And what else is missing in our title signal? Let me check. I think this is what is missing. So now we have global temperature in 1880 to 2023 compared to the baseline period average. So this year extent signal, let me show it in the signal viewer. You can see year extent includes two values, 1880 to 2023. So it's smallest, let me go back. So it's smallest and largest value in the year field. Now we have the title. What else we can do? We can move this title and align it here on the left instead of being in the middle. It's an anchor property which is going to be start instead of the default middle. We can define font size here for the title. Font size is going to be, again, it will be based on a signal which will be title font size. We don't have title font size signal. We need to add it. Again, I can just copy paste the existing one. Title font size is 16. You can see the title font size has been increased now. What else we can do? We can add some subtitle. Let me again open the existing code so I can just copy. Subtitle is going to be just a hard-coded value. So now we have title and subtitle, but we want to add some more space between the title and subtitle. So subtitle padding is going to be 5 pixels. We have 5 pixels more between them. And you can see that we already have almost everything that we needed for this chart except the interactivity. What about the interactivity? How we can add this kind of interactivity? First of all, let me show you fully implemented chart. You can see that the cursor is the rectangle. Rectangle is being highlighted by making it a bit, you can see here on the bottom and on the top, it's a bit longer. So it's visible which one is highlighted. How we can do that? Let me go back to our code. We can add hover property here inside of our mark. And when our cursor is over the rectangle, we are going to move the rectangle beginning along the axis y value 4 pixels to the top, and we are going to increase height of our rectangle. Here, signal here. The height of our rectangle is going to be height of our chart area, or the initial height of the rectangle, and plus 8 additional pixels. So we are moving it 4 pixels to the top and increasing height 8 pixels. So we have 4 pixels here and 4 pixels here above. Now we have interactivity. You can see rectangle is longer under the cursor. What else we can do? We can change, or we can add. Let's add this. Let me show you. Let's add this line in front of the legend. How we can do that? Let's go back to our legend, and not legend. We need to add one more axis, I think. Let's go to our axis. We have axis based on scale X. We have another axis based on scale X. We need one more axis. And we need one more scale. We have scale X, scale color. We don't have vertical scale. Let's add one more scale. Name of this scale is going to be let's call it scale for legend tick. Type is going to be linear. Domain is going to be based on the temp field, same as for the colors. Range is going to be similar to this, but based on the height. So we are projecting all our temperatures to the entire height of our chart area. And we don't need it start on 0 position, so 0 is going to be false. And we need to reverse it true, because we need negative values on the bottom, not on the top, so we are going to reverse it. Now we have this scale. We can create an axis based on this scale. Let's go to the axis property, and we can add one more. It will be based on scale Y for legend tick. We need to define orient property. Orient is right. And you can see that we already have this scale. But we don't need all this label. We need a single tick mark, which will be closer to our legend and which will be interactive, which will be moving, depends on our cursor position. How we can do that? We need to add additional properties to our axis. Domain. We don't need the domain line. It's going to be false. We don't need any labels. Labels is going to be false. We need tick. Tick will be true, but we will need only one tick. We will define it later. Tick color is going to be black. Tick color is black. You can see that we have tick marks. They are black, but they are really small and they are in the wrong position. We need them close to our legend. So let's just offset them 45 pixels to the right. You can see these tick marks here, and we need to make sure that we show only one of them, and its position is dynamically changing. So we add encode property for the ticks, and we will update the following properties. X position of the tick is going to be value -7 pixels. You can see they are longer now because X position is 7 pixels to the left from the default position, and X2 position is going to be 13 pixels to the right from the default position. So now we have much longer tick marks, and the Y position of a tick mark is going to be based on scale, which is scale Y legend for the tick, and on the signal. And signal is selected stripe temperature. Selected stripe temperature. What is that? We don't have this signal yet. Let's create this signal. Signals, and we can add new signal. Name is going to be selected stripe temp. Initial value is 0, and it will be updated dynamically. So we'll need to add on property. On certain events, it will be updated. First event, events. When we move our pointer, our stripe mark, pointer over. When our pointer is our stripe mark, on this event, this signal will be updated with our datum temperature. So when cursor is our rectangle or our stripe mark, then this selected stripe temp signal is updated with value, which is datum, data behind the rectangle, data point that was used to create this rectangle, and temp field of this data. So when cursor is our rectangle, the temperature associated with this rectangle is placed into selected stripe temp signal. Let me show you in the signal viewer. We have selected stripe temperature and it's changed. You can see that this signal value is being changed when I'm moving cursor over the different rectangles. And we need one more event here. Events. The same stripe rectangle. It's named our named rectangles. Marks. Pointer out. So when pointer is not above any named rectangle, stripe rectangle, then update, then value is going to be 0. You can see that when cursor is not over the rectangle, our tick mark is in 0 position. When cursor is over a rectangle, tick mark is moving because of this first event. Add stripe means that we are referencing our named mark, which marks name stripe. So this is how we reference the specific mark. We also can refer all rectangles here instead of specific one, but in this case we need it to interact with our stripe mark. So we use this reference to the stripe mark. And this is how we created an interactive chart. Let me show it full screen. This is basically the complete visualization. In the final version, for which the code is available in my GitHub repository, and I will add the link in the description to the video. Probably there are a few small formatting differences, but overall, we already have all required code complete. And this visualization works as intended. Let me know if you have any questions. In the next videos, I will choose another examples and will explain some additional details about encoding all the formatting properties into your custom Vega visualizations.